Have you ever looked up at the night sky and wondered if we're truly alone? What if I told you that for decades we've been picking up strange, unexplained signals from the depths of space? These aren't just random static. They're mysterious whispers from the cosmos that have scientists baffled and excited. What are they? Where are they coming from? And could they be the message we've all been waiting for? Let's start with one of the most famous cosmic mysteries of all time, the WOW signal. Picture this. It's 1977. Astronomer Jerry Ehrman is scanning data from the big year radio telescope in Ohio. Suddenly he sees something that makes his heart stop. A powerful, narrow-band radio signal lasting for 72 seconds, coming from the direction of the constellation Sagittarius. It was so strong, so unlike anything from Earth or any known natural phenomenon, that Ehrman circled it on the printout and wrote, "Wow." In the margin, the signal's frequency was tantalizingly close to the hydrogen line, a frequency that many scientists believe an intelligent civilization might use to broadcast a signal, like a cosmic calling card. To this day, the WOW signal has never been detected again. Was it a one-time message from an alien civilization? A rare natural cosmic event we don't understand yet? The mystery endures in that single word, wow. Perfectly captures the awe and wonder of the moment. Now, let's fast forward to the 21st century and talk about fast radio bursts, or FRBs. These are one of the hottest topics in astronomy right now. Imagine a blast of energy so powerful it outshines entire galaxies, but it only lasts for a few milliseconds less time than it takes to blink. The first one was discovered in 2007, and since then, we've detected hundreds of them. They're coming from all over the sky, from billions of light years away. Most FRBs are one-off events, like cosmic lightning flashes. But here's where it gets really strange. Some of them repeat. There's a famous repeater, FRB 121,102, that has sent out hundreds of bursts. Scientists traced it back to a small star-forming dwarf galaxy over 3 billion light-years away. Another repeating FRB was even found to have a pattern, a predictable cycle of activity. For 90 days, it's active, sending out bursts, and then it goes quiet for 67 days before starting all over again. What could cause such a thing? The leading theories for FRBs point to highly energetic, compact objects like magnetars, a type of neutron star with an incredibly powerful magnetic field. Imagine a star the size of a city, spinning hundreds of times a second, with a magnetic field a quadrillion times stronger than Earth's. A starquake on its surface could theoretically unleash the kind of energy we see in an FRB. But the repeating nature and the periodic cycles keep the door open for more ... exotic explanations. Could these be some form of alien technology? Perhaps the energy source for an advanced civilization spacecraft. Or maybe even a network of cosmic beacons guiding ships across the galaxy. While scientists rightly favor natural explanations, the sheer power and mysterious patterns of FRBs make them a fascinating puzzle. Each new detection gives us another piece, but the full picture is still just out of reach. Then there's the strange case of Tabby's star, officially known as KIC 8,462,852. In 2015, astronomers using the Kepler Space Telescope noticed something incredibly weird about this star. Its light was dimming in a way they had never seen before. Normal planets cause tiny, regular dips in a star's light as they pass in front of it. But Tabby's star was dimming by up to 22%, and at irregular intervals. It wasn't a planet. So, what was it? The initial theories ranged from a massive swarm of comets to the debris from a planetary collision. But none of these explanations perfectly fit the data. This led to a much more exciting and controversial hypothesis. What if we were seeing an alien megastructure? The idea, popularized by physicist Freeman Dyson, is that a highly advanced civilization would eventually need so much energy that they would build massive structures around their star to capture its power. A Dyson sphere, or Dyson swarm, would be a collection of giant solar collectors. And from a distance, they would block the star's light in just the kind of strange, irregular way we see with Tabby's star. The idea captured the public's imagination. Was this finally it? The first real evidence of a Kardashev Type 2 civilization? Subsequent studies have leaned towards a more natural explanation, perhaps a cloud of circumstellar dust. But the data is still not conclusive. The mystery of Tabby's star serves as a powerful reminder that the universe is full of phenomena that challenge our understanding, and it forces us to consider possibilities we might have otherwise dismissed. And let's not forget the signals we thought might be alien, but turned out to be something else entirely. Back in the late 1990s, at the Parkes Observatory in Australia, astronomers started picking up strange signals they called perytons. They were short, powerful bursts that seemed to come from beyond the Earth, but they didn't quite fit the profile of any known astrophysical event. For years, they were a genuine puzzle. The breakthrough came in 2015, and the answer was, well, a little closer to home. It turned out the signals were being generated by the observatory's own microwave oven. When someone would open the door mid-cycle, it would release a short burst of radio waves that the sensitive telescope would pick up. It's a funny story, but it's also a fantastic example of the scientific process. You have a mystery. You investigate every possibility, and sometimes the answer is much simpler and much more human than you ever expected. It shows how careful scientists must be to rule out all possible terrestrial interference before they can claim to have found something truly cosmic. So, what does all this mean? Are these signals proof of extraterrestrial intelligence? The honest answer is, we don't know yet. For every strange signal, science demands a high bar for evidence. The default assumption, and the most likely one, is that these are new types of natural phenomena that we just don't understand. The universe is a vast and complex place, filled with extreme physics that we're only just beginning to comprehend. Magnetars, black holes, neutron-star collisions. These events are more powerful and bizarre than anything we could have imagined a century ago. It's highly probable that FRBs, the WOW signal, and the dimming of Tabby's star all have natural causes that we will one day figure out. But that doesn't make the search any less exciting. Each of these mysteries pushes the boundaries of our knowledge. They force us to build better telescopes, develop new theories, and look at the universe in new ways. The search for extraterrestrial intelligence, or SETI, isn't just about finding aliens. It's about exploration and discovery. It's about answering the fundamental question of our place in the cosmos. And here's the most thrilling part. We are living in a golden age of astronomy, with new instruments like the James Webb Space Telescope and the upcoming Square Kilometer Array. Our ability to listen to the cosmos is about to take a giant leap forward. We'll be able to scan the skies with unprecedented sensitivity and resolution. Who knows what we might find? Maybe we'll solve the mystery of fast radio bursts. Maybe we'll find 1,000 more Tabby's stars and finally understand what causes them. Or maybe, just maybe, we'll pick up a signal that is deliberate, complex, and undeniably artificial. A signal that ends the cosmic silence and changes humanity's perspective forever. Until that day, we'll keep listening. Because out there, in the vast, dark expanse, the universe is talking. We just need to learn its language. Thanks for joining me on this journey through the cosmic mysteries. If you were fascinated by these signals from deep space, make sure to hit that like button and subscribe for more adventures into the unknown. What do you think these signals are? Let me know your theories down in the comments. I'd love to read them. Until next time, keep looking up.